Welcome to Pavithra Laptop Care. In today's class, I am going to explain 11th gen motherboard, 11th gen motherboard, how it will work. What are the section will be on? Sections will be in on condition before pressing the power button. Okay, so each and every point I will discuss in this section. So before that, you can, if you want same thing in Hindi, pin to pin I already explained in Hindi channel the repair facts. Okay, it's so soon I got 2030 subscribers, 2030 subscribers within 24 days. See, this is the 24th uploaded. The same thing I'm going to tell today in English. Okay, see, this is the one from DC jack I started. Battery, charging IC 19VB, 3VL, IO requirement, EC on, 3 volts always, 5 volts always, 3 volts prime, EC RSM. Before pressing power button, what are the sections will be active? BQ 24781, this one is step down IC. Power sequence, 11th gen overview, motherboard overview. So 19 volts practical, battery practical. This one N channel MOSFET working functions, NTC resistors, RTC, power management, logic circuits, and yesterday it was SPI, bias related class got over. Okay, today more will be there. You can subscribe my channel and watch this for better knowledge. Now same thing I am going to explain in English. Now one concept you need to understand, what are the sections. First, about the section you want to you must know. Okay, so first you will connect the adapter, right, or battery. Once you connect, where you will connect DC jack. So after this one section, the ID section will go to IO and other section go to charging IC. Okay, first section is DC jack, second one is as well as battery also. After that, one section will go to IO, it's a communication one. Second one is charging IC, and then step down IC. Okay, step down IC. After this, again it will connect to IO. These are the main section will be inactive, depends on thermal information. Based on thermal information, these three will be active state. Okay, anyway, so step by step we will watch. First, what section? See, the communication between charging IC, step down IC, and IO will start first. Okay, these three will active initially, because once you connect the adapter, so then you will get the light system. Okay, to get the light, so IO has to work, step down IC has to work, and charging IC has to work. How it will work and what are the input output sections will be active in IO, those things I'll explain you now one by one. Here is the motherboard. This is actually 11th generation motherboard, LAK201P. Okay, this one is top side and this one is bottom side. See, bottom has more components compared to top side. See, here it's very less compared to this one. See, this is actually VIN section. So after that, here some audio something will come, and except that all components will get here only. See, compared to previous motherboards, this motherboard is very easy because each and every ICs has more functionality. Because of that, reduce the component size and this motherboard size also. Actually, motherboard size is little bit big only, but the component is very clear. See, almost all it's lot of distance is available here. Okay, anyway, step by step I will explain one by one. See, this is the motherboard. So once again I'll tell you, part number is LAK201P. So here is the motherboard, processor, SOC. Okay, here is the graphic card. This is IO, and this is the RAM section. Now adapter DC jack. Once you connect the adapter, see, here is the DC jack in the motherboard. So it looks like this. So what are the connections will be there? Here two red, two black, one is empty, other one is brown. This one is yellow or what is that, radium color, and white. These are for what? So in next section you can check easily. See here. So first current flow in red and black. So once you connect the DC jack, here positive and negative will comes. Okay. So once it enters, so through this here LC circuit, so it will filter and pure 19 volts DC you will get. Okay, here is the inductor. Before that some noise will come now. To reduce those noise, parallelly the capacitor will be connected to the ground. Okay, coupling capacitors. So after that coil functions, then also you will get some noise. So reduce that noise, you will get again noise you will get. No, so to reduce those things, again couple of capacitors are used here. Okay, and here one more diode, I mean 3-leg diodes are used here to protect the circuit. See, one is connected to the main power and other one is connected to the adapter signal, because once it connect, any short will happen in adapter side, so then this one will get burned and it will become as a open circuit. So this is for protection ESD diodes. And here is the third one. 1, 2 are positive red, 3 and 4 are black, 5 one is blank, 6 one is adapter signal, that is a brown one, and 7 is the charging LED. 7th one is the charging LED. Once you connect the adapter, so that you will get that orange color light, so that is the one. So next one is AC LED. Once your battery completely charged, then you will get white color indication, right? So that is the pin number 8. See, this is the charging IC section. So this charging IC, what are the things it has connected? Here it has connected to CLR. To CLR. This is also resistor. It's a 1206 size. Okay, 0.01 ohms resistor, only ohms. Okay, to identify the current value and wattage value. So first here is the main CLR and this one is the battery CLR. Using this battery CLR, battery has to work or not, and what current it has, all information it will collect this charging IC. Okay, once the DC jack current enters here, so it will come to first MOSFET and as well as the input to the charging IC. So now this charging IC will active, so because of this 19 in. Okay, once you get this battery connection, battery voltage also will come here as a 19 VB, and that one also is connected to the supply of this charging IC. See, through PQB1, right? So here two kind of input will be there, both or any one input will be there. That input goes to the charging IC. Here 19V in is connected to AC detect also, because once you connect the adapter, the information it has connected, that information has to go to IO. That one who will reach, who will decide, this charging IC will decide adapter is connected or not. Okay, that information goes through the AC signal. So first AC detect is connected or not, this voltage divider will be decide. This was voltage divider, as per the voltage divider 2.4 volts. If it is more than 2.4 volts, then this IC will consider the adapter is connected. Okay, that AC will be in high position. It directly goes to the IO. So next here battery section, battery after this CLR only battery connected, then it will goes to the discharging MOSFET. Okay, first it will enter VIN, it will enter here. The diode is opposite direction, so that is the reason we required gate voltage. This gate and this gate is a common one here, so that gate voltage is connecting by the CLR. Okay, after this once it gets the gate voltage, then it will enter here, it will become as a P1, and then after this it's a forward bias and as well as gate also will be opened, no? So that time it will become as a P2 and finally it will reach the CLR. So this CLR named as 19 VB. This particular plus 19 VB will go throughout the motherboard. So now this functionality already knows everyone. So the one main thing is logic circuits is very, very important to know. So logic, how it will be logic? Logic in the sense it's a conditions. What conditions? Here gate comes, then only it will allow the current, otherwise it won't allow. That is the logic actually. Okay. So here also see, if you get the voltage here, then only it allows to enter the charging IC, otherwise it won't. So here one discharging MOSFET gate also is there, charging first and second MOSFETs gate also is there. But all three should not be equal. It means first and second, when it will be active, then this should be inactive. The discharging MOSFET should be in disable mode. Okay. Otherwise, the battery voltage will enter, and your laptop will turn off immediately. It won't turn on, or it may damage some other components, or either it may get 19 VB short, or it may be get burned, the discharging MOSFET, or maybe first MOSFET also, or maybe IC. Okay, these are the conditions will happen. So that is the reason these two, when it will be on in adapter mode, that time this should be disable mode. Okay, after that it will be the battery voltage will be here, and adapter voltage will be till here. When you disconnect the adapter voltage, adapter, so that time battery voltage will enter here, and it will become as a 19 VB, means it's a 12 point something voltage you will get. So according to the information, adapter information, the charging IC will consider through this CLR the required current is sufficient or not to the motherboard. If it is not sufficient, the information directly it passes to IO and tells the sufficient voltage is not available, so please don't turn on. So that information, this one will pass. Okay, and as well as this battery side also, battery is not sufficiently that required voltage is not there inside the battery, then also that information goes to IO. It will communicate between IO and this one battery. Okay, this charging IC, it makes it does very important role here. Next, see, in the motherboard, the BQ24781, this is the charging IC. It looks like this. Okay, here is the bottom part, and here is the top part. See, in bottom part, here is the supply. This is the diode actually. So battery and normal V-in voltage will enter here, and through the 100 ohms resistor, it will enter to charging IC. So this resistor should be there. You must check this one before doing some other R&D when no power on case. Okay. So this one will enter, and each and every functions I already explained multiple times in same channel. So you can watch, just type BQ24781 and BQ24780S also. So vice versa, both comparison multiple times I already explained. Here is the first MOSFET, second MOSFET, and discharging MOSFET. So how it works, so pin to pin I already given in notes here, just you can read this one, and then you can gain the knowledge. Okay, here is the battery section. See here, battery, it looks like this. It's like a biscuit, and it's very big one. Okay, so it will connect like this. See, PJPB1 is the battery connector. So once it enters through this PL 13 and 14, it enters to the CLR. Okay, this is the battery section. So here battery circuits. So how it looks, what are the pins are there? Here also almost 8 pins are there. See, first and second are the red wire. So directly it goes to the lead L inductor. So after that it purifies and become as a 12.6 volts bat. It means before and after two capacitors are there. This is for filter, I already explained you. So here one more important thing is pin number 5 because it's a 3V LED. See, before we were getting CMOS cell, but nowadays CMOS cell are not available. Even available also through the battery, you are getting the lead voltage, 3 volts lead voltage. Okay. So RTC section will start from here only. RTC supply will start from this section. Here is the communication channel, clock and data 1 and clock 1. See, what are the pin number 3 and 4. This is also very important. It has connected to the 100 ohms resistor. So next, one more important pin is there, that is the pin number 6. It's a battery input or output. See, this information goes to charging IC and IO, both sides. This also goes to both sides. It means charging IC, IO and this one battery section, 3 are connected to each other, and they will talk through this ECSMB clock. Okay, this is the most important thing. See, here is the two resistors always will be equal. I mean, next to that one by one it will be there, because those all are always, when you will get the clock, that time data only will pass. If you don't get the data, then data won't pass. Okay, data is dependent on clock, so that's the reason both resistor you are able to see here in the motherboard. So next, battery information goes to the IO. See, this is the charging IC section. So here the concept which I told you, adapter mode. In the adapter mode, first and second MOSFET should be on, and next the discharging MOSFET should be in off condition. So it should not allow the current from battery side to normal side. Okay, CLR side. So when in the battery mode, these both should be in off condition. Okay, in one side it easily passes from here to here, second MOSFET to first MOSFET, but first MOSFET won't allow the current to the adapter side. Okay, in one. Okay, if it is opposite side, definitely it won't allow the current in reverse. So in battery mode, the discharging MOSFET will be in on condition. That's the reason you will get the battery voltage to the CLR PRB3. This is the CLR. This is the what? See, here one important information I wanted to share with you. See, here is the voltage divider. But here one component is looking like a coil. Okay, the coil. See, here is not a coil. Actually, this is a thermistor, thermal resistor. This is important point. Please note down. This is a thermal resistor. It looks like a coil, but it's not coil. Once the temperature increases, this 100K, initially it will be in 100K mode. Once temperature increases, as per the temperature, this value also will decrease. Once it decreases, the current directly will get short to the ground. Then you won't get any voltage. When the voltage will reduce, the board will get the information the board has overheat, so that's why it has to be turned off. So that information goes to the IO. So please note down this, it's a very important thing. So that thermistor has connected to here also VCC in point. See here PSZ1 and here PSZ2. NTC thermistors are heat sensitive resistor elements of which resistance values rapidly decreases with rise of temperature. With this property, they are used as a temperature protection devices for protecting circuits from overheating as well as temperature sensors. Just I told you, once heat will increases, the value of the resistance also will decrease. So that's why it's called, it's a negative temperature coefficient. Okay, next it's a crystal. Once the V in section will active, then the first PCH part, what is that? That RTC section will get enabled because of this crystal. Crystal also will get enabled because of that RTC VCC voltage. Okay, that one nowadays coming through the battery. Battery has 3 volts lead voltage. Because of that, nowadays that cell, what is the big cell will be there now, that one is not required. So crystal will generate desired frequencies. It's a passive component. Actually, crystal is active and crystal oscillators are passive components. Crystal is dependent on oscillators. That one I already explained thoroughly in a previous video. Please check my videos in this particular channel. So that's it. And again, now one by one I will explain through the charging IC. Here is the charging IC. Once you connect the DC jack, the first charging IC, first IC will get active. That one is charging IC section. Okay, charging IC is BQ24781. It's the latest IC. So IC looks like this. It's a total 28 pin plus 1. 1 is ground and the total is 28 pin. Just a minute. See here it's a 1, 2, 3, 4, 5, 6, 7. 7 total 4, 7 into 4, 28 plus 1. Okay, so total 28 pin over. Next, on the motherboard it looks like this. Here is the white mark. From here it start pin number 1 to 28. Bottom side it's a ground, should be there, that also you have to check. See, this is the bottom portion and this one is the top portion. So one by one pin section I am going to explain. First, once you connect the DC jack and battery, so both will connect to a diode, 3-leg diode, and it enters to pin number 28. Next, After entering the supply, so next CMSRC is the second voltage will generate inside the IC once you connect the main source. Next, once CMSRC is generated, so then immediately your according to the requirement, your gate voltage, it's a 25 volts compared to source. Minimum 5 to 6 volts should be more the gate voltage. Okay, then the gate voltage will active and you will get the 25 volts or 24 volts in the gate terminal. So then these both MOSFETs will get active. In that case, AC, current will enter from here to here to CLR. Next, the main section is first and second MOSFET is get active, right? So to deactivate the third MOSFET, means it's a discharging MOSFET, these two sections will get active, means it's a battery drive and battery SRC. Battery SRC is the first one, and then battery drive gate voltage will start. It may be battery voltage only, it's a 12 volts or something will be there, because it should be in off condition. The equal voltage you will get in the gate also. Next, battery is connected or not, that information has to go to IO. So that's why pin number 15 is here, BI hash. So next, after that, what is that? AC detect pin number 6. See, this is the voltage divider. Through here you will get some appropriate voltage according to the voltage divider. If it is a 2.5 volts more than 2.5 volts, then your AC OK will be in high condition, otherwise it will be in low condition. See, once AC OK is connected, and then immediately internally what is that, a region will get start. So region usually will be 5 to 6 volts. Then if these conditions all are okay, so immediately multiple sections will get active according to the internal voltages. So in that AC OK also one important what is that, a pin. Next, after AC OK at a time, so here one more IADP 7 pin number 7, and here I discharge pin number 8, power monitor, CM comp out, TB state, these all will active at a time once region will generate. Next part is current information has to collect through the CLR. See, through that ACP and ACN, this is the adapter information. Adapter wattage information will be collected through this CLR. Next, at a time in battery CLR, the battery current required and battery charged or not, battery voltage, battery power, all information will get through this CLR. So next, the I limit, current limit pin will get active, that also immediately. Okay, after that, after these sections, once your step down IC will get active, then finally that data and clock will be in active mode. It will communicate with the IO, okay, and battery also. See, next, once the communication will start, then the boost BTST will start. This one is source voltage for high drive side. Next, high drive and low drive will get active, and then high MOSFET and low MOSFET will get active. Means it will start the working functionality. It will start getting work. Next, once it functions, finally your waiting voltage, which one? It's a phase voltage LX charger. It will you will get in the coil, the pin number 27. Phase is the final voltage. So here is the pin configuration of this particular BQ4781 charging IC. Here is the step down IC. The IC number is S5A286A. Here it looks like this. So how it looks? Just a minute. I'll take the pen. See here, AWVCUA. Here is the notch. From here it's a pin number 1 will get start. So now it looks, see, the circuit of this IC is very simple. The pin number, see, pin configuration is here. It's a 1 2 3 4 5 into 4, it's a 20 plus 1, total 21 pin will be there. It looks like this. It's a bottom portion and it's the top portion. In the motherboard it looks like this. This is the complete circuit. Here is the output PL302. It's a 3 volts always. Here is a pin configuration. So first voltage 19 volts V in supply will enter in pin number 2, 3, 4, 5. Next, the enable 2 will decide this IC should be turn it on or not. See, enable 11 enable pin. Pull this pin high to turn on IC. IC should get on once you get the enable 2. Do not leave this pin floating. It should not be vary. Next, once the ICs get active, then immediately 3 volts VLP will get active. What are the pin numbers? 16 and 17. These are power supply for internal analog circuits and driving circuits. Driving in the sense high-low MOSFETs should get active, no? For that it's a supply voltage. And next, mode 12. 12 in the sense enable 1. Enable 1 operating mode selection under light load. Pull this pin low for PFM operating and pull this pin high for PMW sections. See here two operations will be there. One is the PFM and one is the PWM. Here two actually it's a depends on it's a working functionality. What work you want, depending on that you can enable or disable this one. If it is low, it will active PFM section. If it is high, it will active PWM section. It should not be floating. Okay, it should not be vary this voltage. Make sure this has to be constant. Then only you will get the constant voltage 3 volts always. Next BS1, once that pin is active, then BS will be active because of high drive and low drive supplies. Okay, boost trap pin. Next, finally you will get the output in the section of pin number 6, 19 and 20. This is the phase 1. Through this coil you will get 3 volts always. Okay, after that these all functionalities are good, then finally you will get the PG power good in the pin number 9. Here is the power sequence. One by one I will explain what are the sections it's going to be active. See, first these are the power sections. See, 1 minute. Enable. See, first one is RTC VCC, I mean 3 VL RTC till the power button out. Okay, first RTC section will get active. See where it will be RTC battery. See VL RTC. How it will generate? See, I told you RTC cell concept is not there. So according to this, pin number 2 doesn't have any voltage, and here 3 volts VL. As per the 3 volt VL, here the 3 VL RTC will get active. At a time, if you connecting the battery, here also 3 volts lead voltage will be activating the RTC VCC. And at a time here PCH also will get active through this crystal will get active, and first reset RTC RST and SRTC RST, these both resets are the first resets. It's a first and primary, and this one is secondary. At a time intruder will check the door is opened or closed. Okay, and what is that? That's it. Total RTC section will get active through that 32.8678 something will be there. No, that crystal will get active. This is the PCS section, VCC DC PRTC, and finally SOC RTC RST. Okay. Next section is here RTC RST. Next section is DSW. DSW is 3 volts always. So see, 3 volts always DSW section. So next this is DSW PCH power. Okay, the PCH will release, sorry, this one is IO will release PCH DPW power. Okay, next section will be active bat low ash. See, bat low ash is very important. It's a power management bat low. Which one will active? It's a 3 volts prime voltage will active this one. It's a pull up resistor. Through this pull up resistor, the PM bat low will be active mode. Next one is SLP sus ash. SLP sus ash is the from the PCH. It will give to the IO. Next section is sus clock. After that the SLP sus, then sus clock will be active. So next section is VCC in auxiliary. The VCC in auxiliary is the main important voltage for the SOC. Next is ECRSM RST. After these power sections, the ECRSM RST will be finally released by the IO to PCH. Finally, once the EC RSM RST will produce, then AC present will be produced by the produced by the IO, and it will goes to the PCH. Next, the finally power button out will release when you press the power button. So this is the power sequence of this particular laptop motherboard. Here is the final summary before pressing power button on. What are the sections will be active? So let's have a glance. So first thing is, this is the motherboard LAK201P. Next you will connect the DC jack. After that, once you connect the DC jack, adapter ID will go to IO, and AC LED and a charge LED will come from the IO. It's output from the IO. Next, it's a ground, and here it's the pro chart information goes to the input for the IO. So next, the battery section will receive this information. What is that? See, the 19 volts from the DC jack, we will get 19V in, that goes to charging IC, and it will be active. So then finally battery section also will goes to IO and this one charging IC. See, in IO, SM clock and SM data 1 will goes to IO, and battery input connected, it's connected or not, that information also goes to IO as well as charging IC. See, this BI, and battery voltage will goes to the IO, that's CLR part. Next, the see here, it's a most important thing is here the same voltage, the clock and data information goes to IO and charging IC. The main thing is this charging IC, this one is connected, that CLR, right? Two CLRs are connected. This one will decide what kind of current and what kind of power is required to the motherboard to active. That information machine gives to the IO. Next, the IO, battery and charging IC, both three will be connected to each other, and they will talk to each other through the SM bus configuration. Next, here is the current information will collected by the charging IC, and 19VB will active what are the sections. See here, it's 3 volt section and 5 volt section will be active once we get the 3VB section. See, 19VB section, it may be battery voltage or it may be current voltage, adapter voltage. That one 3.5 will be, now it's active one. So next, what are the high-low MOSFETs will be there? All high-low MOSFETs will be get active by this 19VB section. See here, VCC in, that high-low MOSFET will be, high MOSFET will be active, not low MOSFET. Here also high MOSFET, it's a 19VB auxiliary high MOSFET. And next, see here also high MOSFET, it's a VGA core. These are the sections will be active. Using this, we can easily remove the short in case of 19VB section is in short in particular motherboard. See, 19VB, it's a 3.5 volts. Okay, after this 19VB, once it started, the step down IC will get active. Once this one will be active, we will get the 3VL voltage, that LDO voltage. Once this 3VL comes, then it will active RTC, lead and EC, power button out and SM bus. See, again these sub voltages will get active once VL will come. Okay, the one more thing is the lead voltage will come from the battery side. See, after that, once the 3VL come, the PCH will get active and it will active the crystal. Before that, one major first RTC section, what is that? First reset section, SRT, RST and RTC, RST will be active, means it's a reset. Once it reset, then only your motherboard will turn on, and even restart also will happen. If any issues will comes in reset, then once it will on, and after that if you press the power button also, it won't turn it on. Okay, and intruder shows the power supply, that any door is closed or not, that information will collect, and at a time the crystal YC1 will be active. So see, the sub voltage which I told, according to that 3VL, see, the lead will active the lead switch, and EC will active the IO, and all are the CEC RST, NME debug and CPU debug. These all voltage will be in active mode. These are signals, and through that SM bus voltage, this is a pull-up resistor actually. Through that pull-up resistor, this voltage will be active, and it will be pull up to the clock 1, data 1, clock 2, data 2. And next IO will get all these kind of signals first, adapter ID to EC on. So after that, see, please note down, these are the signals will be active in the IO. These are the input and these are the outputs, and bidirectionally SM clock and data. Where are the bidirectional? There will be talk to each other. So finally output EC on and this one main power on. After that 3 always will be active, and we will get the 3 volts always and 5 volts always. Once 3 volts always we will get, these all are the sections will get active, and here 5 volts always, these all are the sections will get active. Please note on this one by one. After that PCH, once it gets 3 volts, then prime volts it will convert as a prime volts, and after that see so many clock data everything will be active mode, and it activates the SPI section also. Okay, see CPU debug, SPI and VCC core auxiliary. Now the vid 0 and vid 1 will be active using that 3 volts prime, and after that finally it will active the 1.8 volts PG also. Bat low, AC OK, wake, LAN, everything will be included before pressing the power button. Next, IO will release after getting these kind of voltage from the PCH. Then IO finally release PCH power enable and PCH DPW power OK and EC RSM RST. After that, the PCH will give what is that PCH power enable using this voltage signal. It will generate 1.8 volts prime and power good. Okay, VGPU power good also, and then finally the IO will really receives the SLP sus hash. Okay, these are the conditions should be there, and then you can easily press the power button. That's it. Before pressing power button, these are the summaries. Please note down. This one is almost all motherboard will be the same condition, same voltage and the same logic will be applicable. Slightly small signals will be vary according to the PCH conditions. Okay, this is the part 1. In part 2, complete section after pressing power button on, what are the sections will active, those things we can check. Okay, I will explain one by one after that. Till the time, thank you very much.